about uh, the security mechanisms in IoT. So we discussed about protocols, MQTT protocol, CoAP protocol, HTTP protocols. So these are basically application layer protocols that we discussed about. And in this application layer, we will be basically transferring data between a certain client and a certain server. Or let's say if it is MQTT, it will be transmitted between certain publishing device and the broker, and then thereby from the broker with the subscribing device. Basically, when we are transmitting the data, we face issues with related to the security. So as you saw in the video, IoT networks are prone to security attacks. So easily they are prone to security attacks, mainly because one of the reasons is that the IoT um, data transmission do not include security features in them. So one of the reasons for not including security features can be that the algorithm or the transmission delay increases once you include the security features or security mechanisms into the communication. If you include security mechanisms into the communication, you add additional latency and additional complexity into the transmission algorithm. So after you obtain the data, you need to encrypt the data using some predefined mechanisms. And only once you have encrypted the data, you will be able to transmit the data appropriately to the receiver. So initially, before sending the data to the receiver, you need to first establish the security features, or you need to establish the secure connection with the receiver, and you need to obtain the necessary data or some information from the receiver regarding the security and regarding secure connection establishment. So therefore, there's some additional delay involved with security-based IoT communications. So, when developing IoT networks, one of the most challenging areas is this security area. So, ensuring security and ensuring privacy of the data is one of the main challenges of IoT networks as of now. So, still research works are going on regarding how we can ensure the security of the data, right? So, still research works are done. So that means still this problem has not been solved. So we are learning about this challenge, which is still persisting in IoT networks, such that so currently we need to find solutions to the available challenges. So meanwhile, there are also some existing methods that are currently used to ensure the security in the data transmission in IoT networks. So one of the main protocols that are used in the application layer are basically MQTT, CoAP, HTTP, and such kind of protocols. So how does security work in those protocols? That is what we are going to discuss in this session. So first of all, I have taken the security mechanisms related to MQTT to discuss. So since we have discussed about the MQTT protocol first, right? However, we will actually learn a little bit more about the security mechanisms in the other protocols such as HTTP and CoAP. So first of all, discussing about the MQTT security features, we can actually have security features established in two different manners. So one situation is given under this first situation, which is the situation where there's a secure or a private broker, or I mean, so a situation that has a private broker, which means that uh, this broker we use as the MQTT broker will be a server which is under our control, which is secured under our um, under our permission, or we have secured that broker for and we have secured it by using certain username passwords, and we have secured the server by ourselves. In that situations, we call that MQTT broker as a secure broker, and that broker cannot be accessed by people who are not allowed to access the broker. So if there are if some external users who want to access the broker, they need to know the username password uh, in order to access the server and access the broker, and they need to know the exact username password. If they don't have, they cannot access this. So in such a situation, then we know that for sure this broker is secure and its security has been enhanced using authentication methods. Uh, However, so in such a case, how does the security features work? So in such a case where the broker is secure, we will be basically doing the encryption at the data that we are trying to transmit. So first, the raw data will be encrypted using a certain encryption algorithm, and the encrypted data will be sent to the broker. And at the broker will decrypt the data and will send the data to the uh, subscriber, right? So the broker can either encrypt the data again, or else if the broker has full understanding about the subscriber, then the broker can send the data directly to the subscriber. So actually the broker can in here encrypt the data again and send it to the subscriber as well. However, in here actually, since the broker is a secure broker, the broker is able to send the data without any um, encryption applied on the data to the subscriber. So in MQTT, we actually have a set of subscribers, and only those devices will be able to obtain the data. The subscriber need to initially inform the broker that that certain subscriber needs some data. So after the broker establishes a secure communication with the subscriber, only the broker is sending some data to the subscriber. So during that initial communication, where the subscriber is informing the broker about its presence, the broker allows the subscriber to access this communication network. So since the broker has understanding and broker trusts the subscriber, then a broker can send the data to the subscriber. So in that situation, the broker has control over encrypting and decrypting the message before sending it to the subscriber. When we talk about the second scenario that can happen with respect to MQTT broker, I mean MQTT protocol. So since the broker is the intermediate party which is involved in the communication, the broker plays a major role in establishing the security or secure communication between the publisher and the subscriber. So the data that the publisher is sending to the subscriber has to be made secure. So at the publisher, the data will be encrypted, and the encrypted data will be sent to the broker. And if the publisher knows that this broker is a public broker, and in that case, the broker will not be having any, like uh, any method to decrypt the data. the broker will not have any data to decrypt the data because the publisher has not shared the decrypting keys with the broker. Right? So we will discuss about the keys, security enhancing, the keys that are used to ensure security. We will discuss about that in a later while. But for the moment, let's assume that this broker in this situation, where we consider a public broker, does not have any information about the keys that it can use to decrypt the messages that it receives from a certain publisher. So if that is the case, the broker directly sends that data that it receives, the encrypted data, to the subscribing device. Subscribing device has the information to decrypt the data, and the subscriber therefore uses that specific data to decrypt the message. So in this situation, only the subscriber can decrypt the message. All right. So in the previous situation, the broker was able to decrypt the message and obtain the original message. But in the second situation, the subscriber is the only person who can decrypt the message and obtain the data. Right. So in the second situation, the broker does not do any decryption. The broker is only there to forward the data appropriately to the connected subscribers. Right. So do you have any questions regarding this section? Right. So I think we will discuss about the security mechanisms of CoAP protocol as well. However, before coming to this protocol, I will discuss about the protocol HTTP and the security mechanisms related to the HTTP protocol first. The reason being that CoAP protocol is similar to the HTTP protocol. I must have mentioned that before. Because of that, when we are talking about CoAP, first we normally talk about HTTP, and we try to understand what happens in the HTTP protocol, and then use that as the baseline to understand what is happening with the CoAP protocol and the security mechanisms with the CoAP protocol. So when we talk about the HTTP protocol, the security features of the HTTPS protocol. So HTTPS protocol stands for the secure version of the HTTP protocol, right? So what are the methods? So what is the method of ensuring the security? Right? So that is what we are going to talk about. So HTTP protocol or HTTPS protocol has basically the request response model to communicate with the other device. So between client and server, the HTTP protocol will basically use the request response model to establish the communication. So basically, the client will send multiple requests, and the server will respond back with multiple responses. Okay, so let's discuss about this. So when we have the HTTP communication, first we will have a section where we send request to the server to establish communication, right? So the initial messages that will be sent to the server will be for establishing the communication link with the client. So the first there will be some sections that will be followed to establish the communication. All those requests will be sent as request responses, and the client will initiate. If the client wants to access the server, the client will initiate a request message, and that request message will be responded back by the server using a certain acknowledgement message, right? So in the initial stage, uh, we call that the TCP handshake. In the initial stage, the TCP uh, protocol will send a message, a synchronous message or synchronization message to the server. So this synchronization message is sent to synchronize the communication link between the client and the server. So the server will give information about the communication link and the synchronization details to follow in order to obtain synchronized data, right? So the client will obtain the synchronized data along with the acknowledgement message. So the client will also respond back with another acknowledgement message, and that will complete the TCP handshake initially, right? So initially they will send some requests and responses back and forth to establish the synchronization details. And so the synchronization details are important for them to uh, send and receive some data um, in a synchronized manner, such that the client can receive some useful data, right? So the client knows at which time the data will be received, and what is the time slot, what is the modulation schemes used, any other details regarding the data that is transferred, which is useful to decode the data, will be sent by the server in this synchronization message, right? So the synchronization message is useful to synchronize the data that is received um, in a suitable manner, such that the data that is decoded will be coherent data or like some useful data. And then once you establish the communication successfully, the next stage for this communication is to establish the security features of the communication, right? So if the client wants to access the server, the client needs to establish a secure communication link with the server. So in order to do that, the client will send another request um, to the server, and the server will share a certain encryption key with the client, and the key will be known as the public key. So there are two types of keys that will be used in this communication. Basically, the blue colored key will be public key, and the other key will be known as private key, and will be given as the red colored key. So the public key will be used and shared, will be available with the server, and the server will share it with the client, right? So initially, to establish a secure communication, the server will first, after establishing the communication link between the client, it will send the public key to the client. The client will, after that, use that key uh, and use that key in the third stage uh, to generate a new key, right? The client will obtain the public key and use that to generate a new key, which is known as an encrypted session key, right? So the client will have a certain secret code, which we call as the session key, and that session key will be encrypted using the public key, and that will result in an encrypted session key. And that encrypted session key is something generated at the client side. The client will use this encrypted session key and will send that encrypted session key directly to the server, and the server will receive this key, and the server will be able to decrypt this key using its private key, right? So after doing so, the server will be able to generate the session key the original session key that was shared by the client, right? So so after that, now both the client and the server do hold this session key now. So after receiving the session key, after generating the session key, the server is now actually server will send a finished message saying, okay, that transfer of messages, transfer of keys is now finished. And after receiving the finished message, the client will be able to transfer the data. The client will encrypt the data using the session key that it has stored in its, in the device level, and use the session key to encrypt the data. And the server will be able to decrypt the data because it has the session key with itself. So the server has knowledge about the session key, and the server can use it to decrypt the encrypted data that it receives. Also, the server will use the same session key to encrypt new data that it is transferring to the client, right? So if the session key is used both by the client and the server, um, then if the same session key is used, then we call that encryption symmetric encryption, right? So, so in this communication, you must have observed that in the initial secure communication establishment stage, we use two different types of keys. And because the keys are different, we call that encryption as asymmetric encryption. So during the initial communication stage, where you try to establish a secure communication and you try to exchange data related to security of the communication, you will be using asymmetric encryption, right? So this is the method used in default for, for establishing secure communication links. And basically during that initial stage, we will be using asymmetric encryption method. After you have established the session key, then we use the same session key to exchange data by encrypting using the same session key, both by the client and the server. So, how does this prevent any hacker accessing this data, right? So that is, I think, the challenge in here. So after we do all these things, we need to stop the hacker accessing the data that we transfer to the client, to the server and the client. So what is the method of stopping the hacker? So the hacker, right? The hacker actually might, like obtain, right? The hacker actually um, do not obtain um, some, it does not have the knowledge of the um, public key. The hacker who's new to this network do not have the knowledge of this public key, and apart from that, the specific session key that the device has, the client has, is also not available at the hacker, right? So the hacker, once it tries to decode any message that this client is sending to the server, the client will not be able to decrypt that message with the knowledge it has. It doesn't have the keys, it doesn't have the public key, and it doesn't have the session key. So the data actually that will be transmitted using the session key. And the session key is basically something generated by the client. So that device level, client information is not available at an intermediate user who is trying to hack this data, right? So if certain device is, if there's a certain network, right? Let's say the network looks like this, and a set of devices are connected through the network in this manner. So let's say a certain device is transmitting data from one end to the destination node at the other end. So if there's some intermediate user who's trying to access the data, right? So let's say this hacker is there in the intermediate position, and the destination device, so the server, let's say the server which is communicating with the client will actually will share the public key in the communication link. So if, for example, if the user, the hacker, obtains the public key, right? Once the server is sharing the public key, let's say the public key was also, found by the hacker. However, right, the public key, let's say it was found, or I mean, was opened by the user, which is intermediate, in the intermediate location, and it has, let's say, the public key. But even though it has the public key, the client is the device which generates the session key. The session key is in the hold of the client device, and this session key is some kind of secret code which is not shared by any other device in the network. And the secret code will be encrypted using the public key, and that the encrypted session key has to be decrypted using the public key, and this decrypted message will be obtained by the will be decrypted. So the session key will be discovered by the server using the public key. So normally, when a user is hacking a certain device or certain data in the network, then the hacker is basically not concerned about the keys that are used to establish secure communication. User who's hacking the network is just trying to obtain any random data that is going through the network through its server, and it's accessing that data and is trying to decrypt that data using the information it has, right? So most of the time it does not do any communication with the server, and therefore the server does not transmit any messages to the hacker. Therefore, the hacker will not be able to obtain uh, even the public key, because the communication that the server does to the client will happen at another time instance when the hacker is, you know, involved with, the with hacking the communication in the network, right? So the public key is actually something that is not visible to the hacker, and the hacker is obtaining data that is transferred by the client basically, and directly tries to decrypt the data without the public key, and without the without the public key it cannot find the session key, and the session key is something that is used by the client and the server for the data transmission process. So during the data transmission process, the data can only be decrypted using the session key. So the public key and the session key are not available at the hacker. So public key, session key, they are not used and available at the hacker, and therefore the hacker cannot actually decrypt the messages that are sent by the client using the session key. So session key is something that the hacker needs to know if it actually wants to decrypt the messages sent by the client, right? So the hacker needs all this data if it actually wants to hack the message. But since the public key is initially, shared by the server with the specific client, and that message was not, observed by the hacker only observes the data that is transmitted towards the server. So the hacker wants to, obtain the data basically, and it will try to hack the data. So the data transmission process is encrypted by the session key about which it does not have any information. So without that information, it cannot decrypt the data. So that is one possible scenario that can happen, and that is one way that the hacker cannot access this system. So when we talk about HTTP protocol, that would be one of the, basic methods of the HTTP mechanism, and how the HTTPS or secure HTTP mechanism works. So this will be the secure mechanism, and you can actually think about this mechanism further in your free time and understand how the basically asymmetric encryption happens using public and private keys, and how the session key is created using the public key. And after that, how the session key is used continuously by the client and the server to encrypt and decrypt the messages. And also we need to know that in the data transmission stage, if we do not use the same session key, and if we use asymmetric encryption, it will actually add delay to the communication, right? So if we are using separate keys for transmitting the data, and then we try to use a private key for decrypting the message, right? Then there will be an added delay at both the client and server in exchanging the necessary keys each and every time they want to do the communication, and they might need to initialize the so they need to do the initial communication of the private and public keys, and then only they will be able to transmit the data. So this additional, features associated with asymmetric encryption will add delay to the communication. So mostly it is recommended to use symmetric encryption for the data transmission process, mainly because we will be using basically one type of key, session key, to transmit and receive the data. So data transmission can be done basically using one key. So basically that certain key will be used throughout the entire data communication process to avoid delays and ensure like low latent or low delay communications. So symmetric encryption is for data transmission. Asymmetric encryption is for initial secure link establishment, right? So secure link establishment can be done under 3 stages. So first you need to establish a communication link reliably with the server. So the client will first initialize the communication mostly, and the communication link will be initially generated. After that, the communication link needs to be secured. So in order to generate security features and generate the necessary secure keys or security keys, there will be 2 other phases, which is second phase, which will be the phase where the server will share the public key with the client. And in the third stage, the client will share a session key with the server. Once those keys are known at both ends, the client and the server, then the communication can start. The communication of the data or the data communication stage will involve using session key only, and that will enable this symmetric encryption procedure. So that is basically regarding HTTPS security mechanism and how HTTPS uses security keys to establish secure communication. And so this is the method that is basically used in HTTPS. So do you have any concerns? Do you have any questions? So CoAP protocol is based on a similar procedure. So CoAP protocol uses a protocol which is known as Datagram Transport Layer Security Protocol to ensure its security mechanisms. So just like HTTP protocol, it has this datagram transport layer security protocol. So we need to know that this HTTPS protocol is based on the TLS protocol, or transport layer security protocol. So HTTPS, basically the procedure encryption procedures are basically built on top of the TLS protocol, the transport layer security protocol. And so this transport layer security protocol is built on top of the TCP protocol that we normally use for HTTP protocols. So transport layer security protocol is used to enable the encryption method in the HTTPS. So when we look at the CoAP protocol, the CoAP protocol works on top of the UDP protocol, and the encryption is done based on the DTLS, or Datagram Transport Layer Security Protocol. Encryption is done based on the DTLS. I mean, under the DTLS protocol. So under DTLS, this encryption procedure is implemented and it's done. So in the datagram, so in the CoAP protocol, datagram based transport layer security protocol is used. So the underlying transport layer protocol that is used is the UDP protocol, or user datagram protocol. So in here, basically due to using UDP protocol, there's a possibility of losing packets, right? So UDP protocol is less reliable than the TCP protocol, right? So when we talk about the reliability, there's a possibility of losing packet in UDP than TCP. So in the UDP, we might lose some packets in the communication. So how do we ensure the secure connection between the client and the server in this instance? Right. So in this instance, the client will transmit messages requesting for communication establishment to the server, and the server will send certain random sequence, which we call as a cookie, to the client. The client will receive the random sequence. That random sequence will be used by the client, and the client will generate a new cookie, or a new secret code using the received key. So just like before in the previous explanation, we discussed about the client receiving the public key from the server and using the public key to generate a new key. So the new key is therefore used by the server, and the new key was shared with the server, and the server has a new key. Just like that, the CoAP also sends a new key back to the server. The server is able to have the new key, right? So initially what we do is we send a request message to the server, right? This request message is received by the server, and the server sends some random sequence to the client. So the client will, after that, will also uh, will send some other message, right? So in here, so the messages are named in a certain manner. So the client will send a message type called client hello, and that message type will be received by the server. The server will send a verify request message, or hello verify request message to the client. So the client will receive the verified message, and that will include the random sequence or the secret code that I mentioned. After that, the client will send a server hello message. That this message is basically sent by the client to the server, where the server will check some more additional information regarding the client. The client will send additional information regarding its device uh, to the server in this stage. So the server will yeah. So the client will send additional messages, and the client will share the session key or the common key that it's going to use in the communication to the server after encrypting that key with the random key that it received from the server. So just as before, the server will share a certain key or cookie with the client, and that cookie will be used by the client, and it will be encrypted by the client into a new key, a new uh, a new secret key, and that key will be shared with the server. So the server, once it receives that, server will investigate the information sent by the client. Server will check whether the client is reliable or not. After ensuring all that, it will send a message, server hello done. Right. So once it's sending that information to the client knows that the procedure has been successfully accepted by the server. So the client will then send a message called finished, right? And then the finish message will be acknowledged by the server, and uh, the the server will send a finished message back to the client. So after receiving the finished message, the entire communication between the client and the server regarding the security communication, or regarding establishing a secure communication between the client and the server will end. So anyway, so basically what we need to I mean know in generally globally is that similar to the HTTPS protocol, in here the client and the server will exchange a certain public key or a certain random number sequence, which we call as the cookie, and the client will generate a new secret code or a new secret cookie, let's say, and that cookie the client will share with the server. So the client will send that a new secret cookie to the server. Uh, After that, the server will after it receives that cookie, the secret cookie, then server will finish the communication. The server will declare the communication related to the secure communication is finished. So the information transaction regarding that will be finished. So after that establishment, the data communication will happen. The data communication can happen with the new secret cookie that was shared between the two devices. So regarding this protocol, you can maybe study later as well, once you have enough sufficient time. So, right. So now I will share the attendance monitoring tool. Is this, are you able to like access this code? If you are not able to mark the attendance, please let me know. I think I have. Right. So with respect to this CoAP protocol, um, I discussed about uh, the functioning basically regarding the communication establishment. And in here, you're sending several message types. So client sends specific messages such as client hello, and the server sends back a message called hello verify request. And so again, the client sends back a message called server hello. And so this actually in this stage where the server hello message is sent, the server is actually checking further further data regarding the client. So the server needs to check the identity of the client in this server hello stage, and once it is done, the server sends a server hello done. After that, the client generates that what the session key in this stage, right? In this stage, the client generates a session key and shares that session key with the uh, shares that session key with the client. Sorry, with the server. So this is the initial stage. So the server will share the public key in here. The server will share the public key in here. And the client afterwards will send a server hello message that will include additional details about the client. Additional details about the client. After that, a server will check the additional data and will confirm the identity of the client, and will send the server hello done message, and server will send that server hello done message. After that, in here, in this place, the session key will be generated, and the encrypted session key will be shared by the client. Encrypted session key will be shared by the client, and will be shared with the server. So the encrypted session key will be received by the server, and it will obtain the session key using, so it has the cookie, and it will obtain the session key using the cookie that it has, that it uses as the public key. So that is the procedure at the server, and that is the way that the server uses to obtain the session key. So the session key will therefore be used for further transmissions of the data in the next steps. So in the CoAP protocol, the CoAP protocol runs under UDP protocol, which is a unreliable, let's say, unreliable protocol when you consider with the TCP protocol, unreliable compared to the TCP. And because of that, in order to ensure that the previous the sessions are secured or resumed, the session IDs. The session IDs are defined for each communication session that is established. So for each communication session that includes a request response has a certain session ID. So so the client and the server has the knowledge of the session ID that was performed already. So if there's a certain session which was interrupted at a certain stage, then that session will be resumed, and basically the session will be resumed from that point onwards. So the entire communication sessions will not restart. Basically, if there's some interruption in this session, that communication link, let's say the communication link was not reliable and the communication was not done properly, then the client and the server will resume the communication from the session ID, the first session, and it will resume from the sessions that it has already completed. It will not repeat doing the sessions that it has already completed. So it will resume the sessions. So that is using session IDs is a way to resume from the previous secure session, right? So in here we will not be repeating the same session. So we will be resuming from the previous secure session using the session IDs that we have used to identify each session. So regarding CoAP, that is basically that I would like to discuss. So CoAP protocol is also having these security mechanisms, and it is also having secure mechanism to send the data. And because of the unreliability of the communication, it uses additional features such as session IDs to resume from the previous secure sessions and to continue the communication regarding the secure session or secure communication link. So that is regarding the CoAP protocol and security features of the CoAP protocol. So with that, I think I would like to end today's session. So also, I would like to mention that I have given an assignment in the LMS for you to complete by the next week. So you can access the LMS and you can complete that assignment that I have given. If you have any questions regarding that, you can ask that during the interactive session that I'm going to have in this Thursday. And you can maybe ask questions related to that if you have. So I will do the interactive session on Thursday. So you can come up with the questions at that time, right? So with that, I would like to end today's lesson. So I would like to thank you for attending this lecture. So